Hello students, in this session we are going to learn a very important concept when it comes to quantitative aptitude. Okay, so I call it as AB equal to C rule. So once you learn or once you understood this concept, you can actually apply it across topics, and I would say, or I can guarantee you, 60% of the aptitude question you can actually connect to this. I have experience in 2 CAT exam. I was topper in 2 exams, so with that experience I'm telling you, you can solve many questions just like that by knowing this rule. Not only in CAT exam, any quantitative aptitude exams or questions, if you see around 60% you can solve just by using this rule. I'll explain this concept. Now AB equal to C, or you can also call it as constant product rule if you want to put it in that way. Okay, see why I'm saying 60% is because if you see the Agarwal textbook or TMH or whatever textbook that you're following, the chapters are divided. Okay, there will be speed, distance, time, there will be time and work. Okay, so all these are different chapters. For example, if you see speed, distance, time, so speed into time is actually equal to distance. Similarly, efficiency into time is equal to work, right? Efficiency into time is equal to work, and also rate of flow into time is equal to volume, length into breadth is equal to area. Okay, rate into consumption equal to the expenditure. So all these you can see, if you see, you can connect it to this. So in all these you can see product of 2, speed into time equal to distance. Product of 2, you will get a result, right? Efficiency into time, you get a result, that is work. Rate of flow into time, you get a result. And how many of you accept that if I'm saying speed into time is equal to distance and efficiency into time is equal to work, both are one and the same? Actually both are one and the same, but it is given as 2 different chapters and 2 different formulas you're actually studying, but there is no point in doing that. And that's why I'm going to connect all these chapters. All these are one and the same for me, and I'm going to propose this rule for you, which will help you to solve around 60% of the questions. Okay, and there is no need to remember any formula. It's all about commonsensical understanding and nothing beyond that. So why I'm saying these 2 are equal? So you can see here, time is common, time is common. Okay, in speed, distance, time, and efficiency into time, work also, time and work also, time is common. Now speed and efficiency, this is also same. For example, if you take the case of a pizza delivery boy, okay, so what is his job? His job is basically, that means his work is basically to travel a distance. So can I say the work is actually to travel this distance? Yes, it is his work. To travel the distance is that work, right? So work and distance is same now. So what is that distance that he need to cover from the pizza shop to the house or the delivery point, right? So the distance traveled is actually the work. Then his speed, his efficiency in this context means what? The speed in which he travel. If he travel at faster pace, his efficiency is more. He can do more work. He can deliver more pizzas in different other places also, right? And if his speed is less, his efficiency is less. So I can say both are same. In that context, I can say this is also same. Right, this is a rate of flow, okay, or this is the volume of the tank which need to be filled. So if you see the volume of the tank which need to be filled, if you take that as the work, then rate of flow is actually the efficiency, and in all these cases time remain the same. Okay, so all these are actually one and the same, and that's why I'm connecting all these and I'm making this proposal that AB equal to C. Now I'm not going to talk about these things, and I'm not interested in discussing about all these different chapters. All these different chapters are discussed at this point of time, and it will be end of it. Okay, so here how I'm going to solve this, and I'll give you examples also. How I'm going to do it is, I'll see here, let's suppose any increase decrease questions. Okay, so here let's suppose A is increased. Okay, what will happen with B? See, this is, I've told you, constant product rule. So product of 2 is a constant. So A, B equal to C. A multiplied by B equal to C. C is a constant. C won't change. See, the distance that you need to cover will not change. The distance that you need to cover is from the pizza shop to the delivery point, or from your office to your house, right? That distance is not changing. Okay, and then work remain the same. Volume of the tank, that won't change, like that. Okay, so C part is a constant. That is what the assumption. A and B are variables. A and B can change. For example, speed can change. If speed increase, time will decrease, right? So A and B can change. That means speed and time can change. Efficiency and time can change. Rate of flow and time can change. Length and breadth can change. But the right hand side remain the same. Right hand side is the constant. So that is how in all those questions how you're going to solve is what we are going to discuss here. Okay. So if you see common sensically, A is increasing, what will happen with B? B will decrease for sure, right? Because C is constant, you can't change C. And similarly, if A is decreasing, what will happen with B? B will increase. So increase in one will result into decrease in other. So both are inversely or directly proportional. These are inversely proportional. So if I'm using a mathematical language, it is inversely proportional. Or I could say in a better way, by using common sense, more of A, it's less of B. Less of A, it's more of B, right? That is a better understanding, and that is what you can keep in your mind, okay? Rather than inversely proportional or directly proportional, etc. So what I'm saying is A, B equal to C, where C is a constant and A and B are variables. So here A and B are inversely proportional. One is increasing, the other will decrease. Now let's see what is that relation, because your questions will be one is increased by this percentage, what will be the reduction in other. So let's try to understand what is the actual reality, how this one increase will lead to the other decrease, and what percentage, what fraction, etc. is what I'm going to tell you. Only 10 minutes you need to give me your attention, and after that all the questions you can solve just like that, okay? Understand this 10 minutes, and then it is going to be so easy for you to solve any such increase decrease questions, okay? So here let's take two numbers. Let's take some simple numbers. 2 into 3 equal to 6. I'm taking simple numbers. You can take any number and you will get the same result. So I don't want to make it complicated. I know the result, so I just need to explain that. So 2 into 3, okay? Now equal to 6. So right hand side is constant, so that remains the same. Now imagine that I'm increasing A. So A I'm increasing to 3. Now seeing this, you know what will be B, right? B will be 2. Okay, so A I have increased, so 2 to 3, and what happened with B? B actually decreased from 3 to 2. So from here you can actually understand how much increase in A will lead to how much increase in B, and we will generalize it, and this is enough. With this example you can generalize it whatever you want. If you want, you can take 3 and 4, you can take 6 and 7, 7 and 8, or any numbers you can take, and you can check it, okay? So here 2 to 3, what is the increase? I would say 50% increase, or rather than saying 50% increase, you can also say like this: from 2 to 3, what is the increase? 1 is the increase. 2 to 3, 1 is the increase. On top of that means from where that increase happened? From 2. So I would write it as 1 by 2. Or 2 to 3 directly you can write 50%. 50% is also 1 by 2. So I need to write it in this format here. 1 by 2 increase is there. So 1 by 2 increase led to how much decrease here? 3 to 2. 3 became 2. So 3 to 2 decrease is 1. So 1 is the decrease. On top of, from where that decrease happened? From here. From 3 that decrease happened. So that is your base. So here 1 is the increase on top of 2. In the next case, 1 is a decrease on top of 3. So we can understand here 1 by 2 increase lead to 1 by 3 decrease. So if I generalize and understand here, if I generalize, if I say 1 by x increase in one parameter, it can be in A, it can be in B. If 1 by x is there, that will result into 1 by x plus 1 decrease in the other. So increase lead to decrease. That is for sure. 1 by x increase means 1 by x plus 1 decrease. 1 by 3 increase means 1 by 4 decrease. 1 by 4 increase means 1 by 5 decrease. 1 by 5 increase means 1 by 6 decrease. What is 1 by 5? 20% increase means 16.6. That is 1 by 6 will be the decrease. Okay, now that's what you need to know. This is only the one thing that you need to know. Now the reverse also is true. Now let's take the opposite. Okay, so you can say, let's write it as 3 into 2 equal to 6. Now consider A decreased to 2. So this is same constant 6. So B will be 3. So here what is the decrease? Decrease is 1 on top of 3. So 1 by 3 decrease. That will result into, you can see here increase, 2 increase to 3. So 2 to 3, there is an increase of 1 on top of 2. From 2 that increase happened, right? So the initial value is what we need to write in the base. We are just finding the percentage only here, okay? So 1 by 3 decrease will lead to 1 by 2 increase. Why this 3? Because on top of 3. Why this 2? Because on top of 2. Why this 1 and 1? Here 1 is a change, here also 1 is a change. So change divided by the base, okay? So 1 by 3 decrease led to 1 by 2 increase. So how can I write about decrease? 1 by x decrease lead to 1 by x minus 1 increase. So if it is decrease, one thing is sure, that is going to be increase in the other. If A is decreasing, B will increase. If B is decreasing, A will increase. So this decrease could have happened in any one of the parameters. It could be in A, it could be in B. So 1 by x increase lead to 1 by x plus 1 decrease. 1 by x decrease lead to 1 by x minus 1 increase. So these are the 2 points, these are 2 informations that you need to know to solve most of the questions in your aptitude exam. All the change related questions you can solve, especially all these topics are connected. Okay, I hope you understood why I'm saying in terms of A B equal to C, because all these many more topics also are there. I'm not writing it here. Many more are connected. So I'm saying increase lead to decrease, decrease lead to increase. How much is what we understood? 1 by x increase lead to decrease for sure, 1 by x plus 1. Since it is increase plus 1. Now that is easy way to remember. Similarly, 1 by x decrease. If it is decrease, there should be an increase in the other. 1 by x decrease, so minus 1, like that. Okay, so I'm seeing here again 1 by x increase, so definitely this is decrease. Since it is increase, plus 1. Similarly, 1 by x decrease will lead to increase. Since it is decrease, here it is minus 1. So plus 1, minus 1. If it is increase, plus 1. If it is decrease, minus 1. If it is increase, decrease. If it is decrease, increase. Simple. I'll give you example with that you will understand in a much more better way. Let's take this example. So let's try to go for a question. Let's suppose there is an increase in sugar price. Let's say 20% increase in sugar price. The question will be, what should be the decrease in consumption? Rate into consumption is equal to expenditure. Expenditure should remain the same. So consumption have to reduce. So let me write the question. The sugar rate increased by 20%. So what should be the reduction in consumption? Okay, so 20% increase in sugar price, what should be the reduction in consumption? So what you will do here, this 20%, how will you write? 20 by 100, right? Percentage you will write like this. So this is nothing but 1 by 5. So 1 by 5 increases there. 1 by 5 increases there. So there will be a decrease in the other, and that's what they're asking. What is the reduction in consumption? So there will be a decrease for sure. What is the decrease? If it is increase, what is the decrease? 1 by 6 decrease, right? 1 by x increase lead to 1 by x plus 1 decrease. So this is going to be 1 by 6 decrease. So you got the answer. What is 1 by 6? 1 by 6 is nothing but 16.6%. That's enough. Okay, now how you are getting this 1 by 6 as 16.6? I don't want you to divide 100 by 6. Don't do that. If it is 1 by 3, you know, right? 1 by 3 is 33.3. So 1 by 6 will be half of it. Similarly, if you need to know 1 by 18, all these, don't do this calculation 100 by 18. If you need to score 100 percentile, don't ever do this, okay? So if it is 1 by 18, all of you know what is 1 by 9. Right, that is 11.11. So 1 by 18 will be half of it, 5.55. So 1 by 18 is actually 5.55. Or if you don't know 1 by 9, at least you know 1 by 3. 1 by 3 is 33.3. Divide by 3, you will get 1 by 9, so 11.11, and divide by 2, you will get 1 by 18. If it is 1 by 36, divide by 2 further. So 5.55 divided by 2, that is 2.77, right? That range you will get. Okay, so 1 by 36 will be 2.77. See, this is very useful in time and work, because you will get questions like person A can do work in 36 days, person B can do work in 24 days. So in all those cases, you need to find what is 1 by 6, 1 by 36, 1 by 24, etc. So never try to do this 100 divided by 36. You can't do this. That's not good. I'm not saying you can't do it. You can do it, but you'll take 2 minutes, 3 minutes for solving the question. I'm talking about the case where you're going to solve the questions in 20 seconds or maximum 30 seconds. I don't want you to spend more time after studying and after attending the class with me. Then there is no point in attending this class here. Okay. So I'm talking about those methods which you will solve the questions faster. Okay, like 30 seconds maximum you will take. So here I got the answer. What is that? 16.66% reduction will be there in consumption. Now see, the examiner can ask you, let's say initially the consumption was, let's say 100 kg. Initially consumption was 100 kg. What is the new consumption? What you need to do is you need to find 16.66 percentage of 100, reduce it. So what is the new consumption? 83.6 kg. See, nobody will give you 100. That I have given you easy value. So if it is 50 kg, initially 50 kg, what you need to find? You need to find the 16.6 percentage of 50, that is 8.3, subtract it, and you will be writing it as 41.6. Okay, so the new consumption will be 41.6. It can be 25 kg, it can be 20 kg, it can be 60 kg. It doesn't matter whatever is asking, but you can obviously find the answer when you get the decrease in terms of percentage. Similarly, the opposite question, if you take instead of increase, the rate of sugar is decreased. The rate of sugar decreased by 20%. Now you can predict the question. What should be the increase in consumption? If expenditure is same, you will increase the consumption. Okay, so what should be the increase in consumption when expenditure remains same? I'm not writing that, but that is also a part of the question. So here directly you will write there is a decrease of 20%. So 1 by 5 decrease. How I'm writing 1 by 5? It is 20 by 100. That is 1 by 5. So 1 by 5 reduction is there. That will lead to, reduction will lead to increase, and that's what they're asking. Increase. But since it is reduction minus 1, so that is going to be 1 by 4 increase. I got the answer. What is 1 by 4? That is 25%. So I got the answer. Okay, so if somebody is saying 60 kilogram was the initial consumption, one more line is there. Suppose initially the consumption was 60 kilogram. Now what is the new consumption? I have told you 25% increase will be there. So what is 25% of 60? That is 15. Okay, 1 by 4 of 60, or if not 25%, 1 by 4 of 60 is 15. Add that 15, so new consumption will be 75 kg. Since the rate is reduced, you increase the consumption. Okay, or let me give you a slightly level 2 difficulty question. This is level 1. I'll give you level 2 and I'll take a level 3 also. The most difficult question which you can get in a CAT paper also I'll take, and I'll explain all the possible questions and the way you need to solve also by using these techniques. Okay, so let's suppose one more question. Traveling at 1 by 5th of the, or 4 by 5th, okay, 4 by 5th of the original speed, a train was 10 minutes late. So traveling at 4 by 5th of the original speed, a train was 10 minutes late. Okay, so what's the usual time? So you may think about speed distance time question and you need to use some formula directly from speed distance time, etc. But that's not required. Once I have discussed this concept, that concept is applicable across topic, and whatever concept I discuss, it's just like that only. You will be in a position to use it in many questions. So here what you can understand, the train is traveling at 4 by 5th of the speed. That means what happened with the speed? The speed is reduced. How much reduction is there? 1 by 5 reduction is there. That's why you're traveling at 4 by 5. 1 by 5 or 20%, right? We will directly write it as 1 by 5. That's easy for us because we need it in that format, right? So 1 by 5 reduction is there. 1 by 5 reduction will be there. Okay, because train is traveling at 4 by 5th. So 1 by 5 is a reduction. Now, if we know 1 by 5 reduction in speed, what will be the increase in time we know, because distance is constant. Here distance is constant, right? So what should be the increase in time if 1 by 5 reduction is there? Reduction means there will be an increase in time. So this is time. Time will increase. 1 by 5 decrease is there, so time will increase. So since it is decrease, minus 1, right? So time will increase by 1 by 4. So 1 by 4 increase will be there. Correct, no? So we know time, that means let's suppose usual time is t. Let's suppose usual time is t. From t, 1 by 4 increase will be there. Just like before I told you, if the initial consumption was 60 kg, now it should have been increased by 1 by 4 and 75, right? Similarly, if let's suppose original time is t, now from t there should have been an increase of 1 by 4, and that increase is given. How it is given? It is given that the train is 10 minutes late. 10 minutes late means it is the increase in time. So can I say 1 by 4th of the time, actually 1 by 4th of the time is actually given as 10 minutes? Then you can find the time as 40 minutes. So what is the answer for this question? 40 minutes. You use nothing apart from this logic. So what they are saying is 10 minutes late. 10 minutes late is obviously, we know 1 by 4 will be the increase. So 1 by 4 is actually 10. So you can directly get from that 40 minutes. Now I'll give you a slightly difficult question. I don't want to put it in words. I'll show you in a diagram. Let's suppose A to B. This distance from your home to office, okay? Or let me mark it as home to office. So in words they can give you anything: home to office, school to office, school to home, whatever it is, it doesn't matter. A to B, PQR, etc. It doesn't matter. So you are traveling from one place to other. So let's say if you travel at 4 km per hour, okay, you will reach here 20 minutes late. So this is a very classic question in CAT exams, okay, earlier. And if you travel at 6 km per hour, you are 10 minutes early. You might have seen this kind of question across your aptitude papers, and this is normally very difficult to solve, but I'll tell you how you're going to solve it in a flash of seconds, okay? So here 4 km per hour, if you travel, you're 20 minutes late. Now if you increase your speed, so when you reach 20 minutes late, you may miss your half day attendance, or you may get fired, okay? So because of that, you increase the speed, so you are reaching early. Reaching early is not a problem, right? See, this question can be asked in many ways. I could have asked you, when you increase the speed, earlier 20 minutes late, now you are 10 minutes late. This is one scenario of asking this question. Or I could have also said that when you increase the speed to 6 km per hour, now you are reaching on time. That means, let's suppose 10 a.m. is your office time, now you are reaching exactly at 10 a.m. So reaching on time. This is another possible question. Now, or I can say 10 minutes early, or 20 minutes early, or 30 minutes early, like that I can ask you. So I can still ask you a question on late and on time and early. I've asked you the slightly more difficult one, that is early, okay? So let's try to see how you're gonna solve this particular question. Okay, so if you travel at 4 km per hour, 20 minutes late. If you travel at 6 km per hour, 10 minutes early. Now if you look into this, what happened with the speed? Speed is actually increased. So this is clearly an increase-decrease story, so we can apply our method. If speed is increased, what will happen with the time? The time will decrease, and that's what exactly happened here. Earlier you were late, now you are early. But why? Because travel time is reduced. Okay, now let's see how much speed is increased and how much time is decreased. With that, okay, the question is basically to find the distance. This distance is what you need to find out. Okay, so that's why it is slightly difficult. You cannot connect distance with anything else here directly. So what we need to do is we need to find the speed and time. Then you get the distance. Speed is given in two cases. So corresponding time, if you can get the distance. Either at this speed you get the time, or at this speed you get the time. In any case, if you get the time, you will get the distance. Distance in two cases are same. So what is the increase in speed here? 4 to 6, that is how much increase? 50% increase. Or you can say 2 is the increase on top of 4. That is nothing but 1 by 2 increase. Okay. Or how to calculate this percentage faster? Let's say 2 to 4. What you need to do is take the factor of multiplication here. Multiplied by 2, you will get 4. 2 into 2, you'll get 4. Or 4 by 2, you'll get 2, right? So take the factor of multiplication. Minus 1, you will get 1. Add 2 zeros. Okay. So this is in case of 2 to 4. Okay. So 2 to 4, you get 100% increase. Similarly, if you see 3 to 9, you can see here factor of multiplication is 3. Minus 1 if you do, you'll get 2. Add 2 zeros, 200%. If it is 10 to 9D, what is the factor of multiplication? 9 is the factor of multiplication. Minus 1, you will get 8. Add 2 zeros, 800%. What about this 4 to 6? 4 to 6 is 1.5. 1.5 minus 1.5. When you add 2 zeros, first zero will make it 5, second zero make it 50%. That's why I have written 1 by 2. So this is how you can find the percentage change faster. I'll discuss this in detail when it comes to data interpretation. Don't worry about this. I'll teach you all the methods in which you can solve data interpretation faster. All the percentages, averages, everything. Okay. So 1 by 2 increase is in the speed. How much will be the decrease in time? We know that. 1 by 2 increase means 1 by 3. 1 by x increase means 1 by x plus 1 decrease. So 1 by 3 decrease will be there in the time. Right? Now how much is given here? See, let's suppose 4 to 6. That is 1 by 2 increase. So 1 by 3 decrease will be there in the time. Right? Now how much is given here? 4 to 6. That is 1 by 2 increase. So 1 by 3 decrease will be there in the time. Right? Now how much is given here? See, let's suppose Earlier 20 minute late, now 10 minute early. So what is the change in time? Is it 20 minute or 10 minute or 30 minute? It's 30 minute. If you get that correct, then you got the answer. Why it is 30 minute? Let's say earlier you need to reach at 10, if 10 a.m. is the office time. You need to reach exactly at 10 a.m. Earlier, what is happening? You are reaching at 10:20. So you are late, 20 minute late. Now you are reaching at 9:50. So you see the time change. When the speed increased from 10:20 to 9:50 gained, right? So basically what happened is you overcame this late time and you gained some 10 minute. So effectively, what is the time change? 30 minute is the time change. You get that, you got the answer. 30 minute is a time change means you can see 1/3 decrease will be there. That is 30 minute, just like what we have done before. Earlier we have understood 1/4 increase in time, 10 minutes, so we got 40. Here 1/3 decrease in time, that is what we got as 30. 1/3 decrease from the usual time. Usual time means I am talking about the first case. From the first case only you are reducing the time, no? So when you travel at 4 km/h, you have taken some time. That I take it as the first time, that is the usual time. From there is a 30 minute reduction. So this T is your, let's mark it as T1. Okay, see, you can find that T1 because from there only this 30 minute reduction has happened. So what is T1 now? That is 90. Okay, so that means when you travel at 4 km/h, you are taking 90 minutes. That's it. So if you're traveling at 6 km/h, how much time you're taking? 90 minus 30, because there is a change in time. 90 minus 30, that is 60 minutes. But that is not required. As soon as you get this 90 minutes, you got the answer. Why? Because distance is what asked. Distance is speed into time. We know the speed here 4 km/h and 90 minutes. You got the answer. Speed and time you got, right? So 4 into 90 divided by 60. So you get 6 km. So the distance is 6 km. Now I'm telling you, there is no need to find this time. But since I have told you, first one is 90, I can get the second one also, that is 60, because 30 minutes is the difference. Now you can find distance by using this also if you wish. It will be the same, right? 6 into 60 by 60, you will get 6 km, because distance is constant in both cases. So distance you are getting constant. So what all could be the questions which can be asked here? They can ask you time T1. That means what should be the time taken in the first case when you travel at 4 km/h. They can ask you time T2. That is what is a new time taken. Okay, they can ask you distance. So these are the 3 questions. Apart from this, 2 more difficult questions can also be asked. Okay, what should be the correct time, or what should be the time you can take so that you will reach the office without being late or early? See here, if you take 90 minutes, you are 20 late. So 90 minus 20, that is 70 minutes is what you can take. Or if you take 60 minutes, you are 10 early. Then also 70 minutes is what you can take. Or the last question, which is slightly more difficult, what they can ask is, what should be the speed in which you need to travel so that you will reach the office without being late or early? Here speed 1 is what? Speed 1 is there, that is 4 km. And the question is asked about time 1. Speed 2 is about 6 km. And the question is also asked about that. So here the answer is 90. Here the answer is 60. And distance is asked, that you can use speed 1, speed 2, speed 1 or speed 2. Or speed 1, time 1, speed 2, time 2, you get the distance. So distance also you got. Now this was also another question, that is a time T3. What is the time T3? T3 is the time which you can take to reach the office without being late or early. That is 70 minutes. And if T3 can be asked, you can get a speed 3 also, which is not asked here, but it can be asked. If that is asked, that will be the difficult question. Why? Because the question is going to be asked in this term, what should be the speed in which you can travel so that you will reach the office exactly at the same time without being late or early. So it is easy. First you need to get the distance. I got the distance, that is 6 km. Now what is asked? Speed is asked. Speed is distance by time. So I got the distance and I know the time you can take, right? 70 minutes. So I should take 70. I cannot take 90 or 60, because the question is you should reach the office without being late or early. I know the distance and I know the time that you can take. So you can adjust the speed. So 6 km by 70. 70 by 60. So you'll get the answer. So these are the 5 questions which is possible from this case. These are the only 5 questions which is possible in this case, and that's the confidence that you need to have, and these are the better method to solve this question. Any of this 5 question, this is the best method that you can ever go for to solve this question, and there is no need to remember any formula. Only the concept that we have learned is what we have used. Okay, so if you have any doubts related to CAT preparation, okay, I can help you. I was 2 times CAT topper, so any doubts you can get in touch with me. I have my personal classes, I have my mentorship program, guidance is there, and then CAT classes are there, regular classes there, live classes there. Apart from that, online recorded classes also there. So I'll take care of quantitative aptitude and data interpretation. Okay, so see you guys. Thank you.